Hello and welcome to another C++ tutorial. So this time around we are going to be taking a deeper look at access levels. So we've seen a little bit of them before, public and protected and private, and if you've come from C#, those will be somewhat familiar, but we're going to take a much deeper look at them today and look at a couple of things that you can do in C++ that don't exist in things like C#. So let's dive on in. So to begin with, I'm going to set up a couple of classes so we can easily demonstrate how the different things work. I'm going to set them up all in the main file, just for ease of being able to demonstrate things. I wouldn't normally do it this way, but it just saves me jumping between lots and lots of files while I'm demonstrating the things. So I'm going to have a class that I'm going to call grandparent. I'm going to give it a public variable. So we'll call this, let's give proper naming, public1. And then I'm going to have class parent, which will inherit publicly from grandparent. And one of the things we are going to look at is the difference between having public or protected or private there for that. Then with this, so what I'm going to do is have protected, protected 1, and also have private. So private. So I'm going to have this be parent A, and then I will also have a parent B. Then in here, and for demonstrating this, it doesn't really matter whether this function is public, protected, or private. It's really just about demonstrating how it actually works. So demo function 1. So with this, okay, well, standard cout of public 1. That I can do no problems because the variable's public. We kind of expect that. So if a variable or a function is public, then it's able to be accessed by anything within the class and anything outside of the class. So public, fully accessible. So accessible, inside, and outside of the class. If I then go for accessing the protected variable, which I'll actually give these some initial values. So again, the protected one, I can access that. So accessible inside the class and by any descendants. So I'm saying descendants because it's accessible by children of this class and children of those children, etc., etc. So anything that has at some point as a parent this grandparent class is going to be able to access protected variables, protected functions. Now if I try to access the private one, and we can see straight away it's giving me an error. So this will not work. Let's actually comment that out. Only accessible inside the class. So that gives us a good range of control over things. It gives us quite a good range of control over them. And so, okay, we've seen here public, protected, private. Whether it's applying to a variable, whether it's applying to a function, it doesn't actually make a difference. It works the same regardless. So we've seen the fact of how things are accessible within the function and outside of it. So down here, if I grabbed these, and we'll be able to see, I'm going to create parent A, variable 1. And with these, if I just do variable 1, then we can see the protected one also, as expected, won't work because it's not accessible outside of the class unless it's by something that is a child, grandchild, etc. of it. What about the scenario where, okay, let's have a protected variable here and int protected 2, that's 11. Let's have a function here, and it won't matter what the access level of it is, but let's make it a fully public one. Demo function 2. So, okay, let's say I created a parent A here. Then, okay, these two, parent A and parent B, are essentially siblings. So let's see, can I access protected variable of a sibling? Public, yep, able to do that. But protected, I can't. So protected only applies to something that is, only allows access to descendants. It doesn't allow access to siblings. So that's an important thing. Protected does not give access to siblings there. So, okay, that's a little bit of how those different access levels work in terms of how you should approach it. So things that are public, here's what you should assume. If you make a variable public, you are saying that it is fine for anything outside of it to make changes to it. If that's not the case, that variable probably shouldn't be public. The same is true of functions. If you make a function public, you are saying it's safe to run this function. So if it's not, it shouldn't be public. And we follow that same process with deciding, okay, well, if it's not safe for it to be publicly accessible, let's evaluate protected. Is it, and we ask the same questions, except now, is it safe for all descendants to be able to modify this variable at any point in time? If it's not, it shouldn't be protected. If the function is not safe for a descendant to run at any point in time, it also shouldn't be protected. So it comes down to that aspect of safety. What is going to be safe to do at this particular point in time? If it wouldn't be safe to do that, then we don't make it that access level that would permit it. So we always try and have the most restricted access level and always view it from the point of view of whatever access level you're setting it at, that's who you're saying it's safe to be able to access it at any point in time. And that may mean that we have things like, okay, well, I've got a variable that it's not safe for anything to access it other than things internal to the class. It has to be private, but other things might need to read from it. Then you can add a getter function to it. So add a getter function that allows you to read that variable, and it could give back a version of it that's const, for example, or it could give back a copy of it depending upon what's appropriate to the scenario. But that's something where you can do a getter, and while that adds more code, we're preserving the safety of the code. And that's the big thing. What you set as the access level is who you're saying it's safe to be able to run it or to modify it at any point in time. It's an important way to be viewing it. Now, C++, being what it is, for everything where it provides generally a tool to restrict something, it generally provides a tool to bypass that restriction. And the same is true with this concept of being able to restrict what things are accessible. C++ does make it possible to bypass the access level restrictions. And it's something that don't really have a full direct equivalent in C#. You can get close to it with the internal keyword, but you can't get fully there to the same extent that you can in C++. So what I can do is I'm going to set up, so we will have another class here that actually I'm going to create a parent C. And this will have demo function 3. And we're going to see, can we make it so that we can access the protected and private data here. So what I can do is I can here say that parent A is a friend of class parent C. So we've declared that parent A is a friend of parent C. Now you'll notice that now allows me to access the protected one. Still won't allow me to access the private one. So you'll notice that's allowed me to access the protected variable. And I should be able to access protected 2. We'll double check this by, we're going to create a parent C variable 2, and we're going to just make sure that we're running that function, because sometimes things don't always get picked up until we're actually running them. So this does not work. We can access those protected variables, which if I remove the friend declaration, we'll see it goes back to I can't access any of those ones. But with the friend declaration, I can access protected 2. But I can't access the private one. Well, what if I create it locally? Maybe it's because the private variable there is in the grandparent. Let's check. Private 2. So let's see if we can output private 2. Notice we can. So, and we'll double check by actually running it. That we need to make sure we comment out this one because we know this is not valid. So we can see we did get a bunch of ones output. So that's good. So friend has allowed us to access information that is private and protected within this class, but because the friend declaration is on parent A, it's only going to allow us to access things that are protected or private level of visibility to parent A. Because private 1, parent A can't see it either. Protected 1, parent A is able to see it, so by doing the friend declaration, that allows parent C to see it, but private 1 is inaccessible to parent A already, so a friend declaration here won't allow access to it. Now, you might then be thinking, cool, I can use the friend declaration everywhere. And yes, you can. But using friend declaration should be something where there are moments where when you're writing code and where you're writing particular sections of code that there should be moments of pause, that there should be moments where you double check and ask yourself, should I actually be doing this? Is doing this the correct thing to do? And adding in a friend declaration is one of those ones. That should be a moment where you look at it and go, okay, is this the best? Is this the correct way to be solving this? Or is there an architectural issue that I'm working around? That's always an important question to ask. And that's the thing. Those moments of pause are usually when you're trying to assess, is this an architectural issue or is this a valid, normal, like sort of thing that's reasonable to be doing? In some cases, yep, it's going to be completely valid, completely reasonable to be doing it. In other cases, it might be a sign of an architectural issue, and you should actually look at potentially redesigning the code. It may not be the appropriate time to redesign it, so it might be something where you note it down for later, but that's the thing. Just because C++, as I said, it's a language that gives you a lot of tools. It gives you, as I think I've described it before, it gives you all of the pieces to build a safety railing, but whether you choose to build that railing is up to you. And that's very much the case. It gives us all the tools for controlling and for providing safety, but where and how we use them is up to us. And it's very easy to have poor architectures where we end up bypassing things. And as I said, it provides a lot of tools to bypass things. So yes, if you find you are writing a friend declaration, then make sure that it's not an architectural issue and that it might not be a better way of doing it. The other thing you'll notice with this is I've done friend class parent C. What if I remove that class? So I've removed class from there and it's not showing me an error. But if I go to run it, it actually doesn't work. It doesn't know what parent C is. Although it's not smart enough to be indicating that this is an error, there is actually an error here. And the reason being is that, so in something like C#, every class, thing like of that declared at the top level of a file can see everything else regardless of order in the file. That's not the case in C++. Order matters in C++. You can only see things that are above you. And that can get very tricky because while yes, we can in many cases order things so that things are only needing to access things above them, that's not always the case. But C++ provides us a tool to get around that. We can do what's called forward declaring things. So when I am doing friend class parent C, I am actually, as part of that, saying that A is a friend of C, and that means then that it's able to see the things inside, C can see the things inside A. But I'm also for declaring there to an extent that parent C is going to be a class. The other solution I could adopt is I could actually go class parent C, like that. This is what we refer to as a forward declaration. So that would mean I wouldn't need have class there. We can test that out and we can see it still runs fine. So two different ways of how we approach it. Really what I would use as a deciding point is, am I going to need to be working with parent C multiple cases in here? If I am, then I'd probably do a forward declaration, especially if there's multiple classes that might be needing it. Otherwise, I would actually just do it as part of the friend declaration. So two different ways of doing it, depending upon your particular needs. But that's just a way of working around that issue where, these things do depend upon order. So final bit with friend. So I have said that C is a friend of class A. But does that then mean that A is a friend of C? Is A going to be able to see the private or protected data within our parent C class? So let's find out. We're going to have protected 3 like that. Now I'll set up another function here, demo function 1a, and what I'm going to do is parent C, variable 1, standard cout, variable 1, and we can already see it's not listing it. And just as a test, I'll also put in the public variable, just so we know that it definitely is able to access stuff. So, okay, you can see that it can't access it. And we can double check, we'll compile just to make sure. So, yep, saying that it can't access it. Comment that out. Let's make sure that it actually runs. And we'll see that it also still doesn't work, because while I've said that parent C will exist and it will be a class, it doesn't know anything about it. It doesn't know the layout of it, the structure of it. So this is honestly why we have that split between header and CPP files. So what I'm actually going to do is down here, have to put it like this so that it is below where we've actually fully defined what parent C looks like. So we have the function down here now. So, okay, what I will do, again, just making sure that that function is being run. So let's test that. Does it compile and run? Which it does. So, okay, when it moved down, can we access the protected variable? And double check with trying to run, and we still can't. So friend allows access, but friend is one way. So this is saying that C is a friend of A. Parent C is a friend of parent A. One-way friendship. So it doesn't mean that A is a friend of C. If we wanted that to be the case, we would have to, down here, say friend parent A. So the friend keyword, that friendship relationship, is one way. It's not a reciprocal friendship. If you want it to be, then you need to be declaring that in both. But again, that should be even more so, I would say, a warning flag of should you be setting things up like this. That's, I think, a fairly big warning of potential architectural issues. So just something to be aware of with that. Okay, so finally, well, we've seen that there is an access level being used here when we do inheritance. So let's find out what breaks when we actually go and do inheritance. So what I'm going to do is I'll do this here. And because parent B is not really used much by anything else, so it's going to have a version of this function that is largely the same. We will down here just create a parent B 3 And I'm actually going to rename that function to 4. And I'll put this below here, like that. So firstly, we'll just make sure that it runs. So yep, everything runs. That's good. So let's change this from public to protected. Easiest way to illustrate what happens is by changing it and seeing what, if anything, breaks. So this is a really important thing, is when you are working with code on that, don't be afraid to experiment and to test out, try and actually see what breaks. So, okay, change it to protected. Everything still behaves. What if I change it to private? So far, everything still behaves. So, okay, largely looks like nothing is different. What if I go and have a child A that inherits, and we'll say it inherits publicly from parent B, and we will give it a demo function 5. Again, we'll set it up down here, similar to this. This will be child A, variable 4, demo function 5. So at the moment, nothing should be different. Everything should still work exactly the same. Let's change this to protected. Does anything change now? Do that. Nope, nothing changes. What if I change it to private? Does anything change? And we'll notice we're already getting errors. So, okay, we do immediately see changes, and that gives us a bit of a clue as to what we might find down here. So with this, we were able to access public 1. Can we do that currently with variable 3? You'll notice we can't. It's inaccessible. So this gives us a bit of a clue as to what's happening. If we change this to protected, then, okay, these are, whoops, this one, I want it to be public. If we change this to protected, then these now work, but this one down here is now broken. So what this does when we set an access level here is it goes and essentially sets what the maximum access level is of anything that gets inherited. So anything that was public is going to get bumped down if we had this as protected or private. It'll get lowered to that. And if we had it as private, it will get lowered to things that were protected will get lowered to that. So it's essentially setting what the maximum access level is of things that are inherited. It's not something that we commonly use, but if you do have a case where you're inheriting from something and you do want to increase the restrictions, you do want to obscure more of the data for various reasons, that's how you can actually do it. It's not commonly used. I've very rarely seen it used, but that's not to say there aren't cases where you might want to actually do that. So if you did want to take the variables of a parent class and say, okay, here is what their maximum access level is going to be going forward, you can do that. So it can be really handy in that regard. So, okay, we've seen a bunch of things there with access levels. We've seen ways of bypassing them. So the main things to remember with this are, if you find you're writing things like friend and that a lot, That's a moment of pause for assessing whether the architecture maybe needs to be changed or improved. And in terms of the access levels, the question you should be asking yourself is, for a variable, who am I happy to be able to change this at any point in time? For a function, who am I happy to be able to run this at any point in time? Those should be your guideposts essentially for deciding what that access level ends up being. But dive on in and experiment with it. Experimenting with the code is a really great way of being able to learn different things and to figure out the kinds of things that you can do. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out, it's really appreciated. If you're looking for the code for the project, the code is available up on GitHub, and there is a link to that in the description below. If you've got any questions, chuck in a comment. If you're trying to track down other videos, I do have a searchable video archive, which I've put a link to that in the description as well. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description also. But until next time, bye.